This is Spacetime, Series 26, Episode 141, for broadcast on the 24th of November 2023. Coming up on Spacetime, China to undertake a Mars sample return mission ahead of NASA and ESA, an alternative cosmic source for gold, and NASA's next cosmic map maker. All that and more coming up on Spacetime.
Welcome to Spacetime with Stuart Gary.
While NASA and the European Space Agency are continuing with the development of their Mars sample return mission, which is slated to launch sometime around 2030, China's just announced its own plan to get samples back from the Red Planet before them. It's the latest in a growing list of endeavours being undertaken by Beijing in a new space race against the West. As part of its goal to become a space superpower, China has announced an expansion of its Tiangong space station and the creation of a joint lunar research station on the Moon in partnership with the Russians. China's also planning on sending its own manned mission to Mars and will undertake a sample return mission in preparation for the arrival of taikonauts on the Red Planet. According to Beijing, the mission, named Tianwen-3, will involve 2 launches in 2028, an orbiter Earth return vehicle and a Mars lander ascent vehicle. Tianwen-3 follows on from Tianwen-1, which launched back in July 2020 and involved a spacecraft consisting of 6 vehicles, including an orbiter, 2 deployable camera CubeSats, a lander, another remote camera CubeSat, and the Zhurong rover. The spacecraft, with a total mass of nearly 5 tons, was one of the heaviest probes ever launched to Mars. The mission successfully landed on the Martian Utopia Planitia in May 2021. The Zhurong rover then spent more than a full Earth year exploring its surrounding environment. It was finally placed into hibernation mode in May 2022 to prepare for the approaching sandstorms and Martian winter. However, it never woke up. Tianwen-2 is a planned Chinese asteroid sample return and comet exploration mission. It's currently under development. The current plan for Tianwen-3 envisions 2 launches during 2028 using Long March 5 carrier rockets. One launch, occurring in November 2028, will send an orbiter return vehicle on a trans-Mars injection trajectory. The spacecraft's anticipated to enter Mars orbit in August or September 2029. The second launch, either in May or December 2028, will send a lander and ascent vehicle to the Martian surface, with potential landing dates in August 2030 or July 2029 respectively. Once the lander arrives on the Martian surface, it'll collect samples, possibly using a drill on the lander itself or by way of an autonomous mobile robot with multiple legs. Then, in October 2030, after several months on the Martian surface and after storing samples collected by the lander and mobile robot, the ascent vehicle will launch from the lander and rendezvous with the waiting orbiter. The ascent vehicle will then transfer the collected samples to the orbiter return vehicle, which will then depart bound for Earth, also in October 2030. Those samples are then anticipated to arrive on Earth by way of an atmospheric re-entry vehicle in July 2031, beating the Americans and Europeans and giving Beijing much kudos and pleasure. This is Spacetime. Still to come, an alternative cosmic source for gold, and construction underway on what will be NASA's next cosmic map maker. All that and more still to come on Spacetime. A new study suggests that the explosion of a low-mass neutron star could be an alternative cosmic source for heavy elements, including precious metals such as gold and platinum. Neutron stars are the superdense cores of stars with masses between 10 and 25 times that of our Sun, which have exploded as supernovae at the ends of their lives. After the final explosion, the star leaves behind a sort of stellar corpse, an extremely compact object with a mass somewhere between 1.4 and 2.3 times that of our Sun, but a diameter of only about 20 kilometres. In other words, a neutron star. These objects are so dense that just a teaspoon of neutron star material would weigh billions of tons. In fact, the only thing denser than neutron stars are black holes. An object as compact as a neutron star is stable enough to exist on its own, but they're often found in binary systems, and its interaction with a companion neutron star can trigger some dramatic events. Now, traditionally, when two neutron stars are close enough, they'll merge and collide, resulting in a kilonova explosion. These are known to produce heavy elements, including precious metals such as gold and platinum. In fact, such a merger was recently observed for the first time in 2017. However, it's highly uncertain if this method alone is sufficient to explain all the heavy elements we see on a cosmic scale. And that's where this new study comes in. Its authors noticed that even without direct collision, primary neutron stars can lose mass to a companion neutron star simply through gravitational tidal forces. Their findings, reported in the Astrophysical Journal, use new theoretical models to show that after shedding enough mass, a neutron star will become unstable, and that can trigger uncontrolled pulsations and later an explosion. The authors then investigated whether or not this explosion could synthesize comparable elements that found in a kilonova merger. There have been very few previous studies looking at this process because the modelling is computationally very difficult. It involves calculating extensive nuclear reactions and accounting for the extreme environments around neutron stars which aren't fully understood. To make sure the chemical elements were correctly calculated, the authors used a large nuclear network of more than 3,000 isotopes with the most updated microphysics. Their results confirmed that an individual low-mass neutron star would be unstable, and that would mean it could explode. And the chemical composition of the ejector closely resembles the solar composition, especially in heavy elements. And this suggests that the scenario could be another important way of explaining the chemical element distribution in the universe today. The study is shedding new light on one of the fundamental questions about the universe: where all the chemicals came from. And how did the universe evolve from only having hydrogen and helium with just a sprinkling of lithium, all of which came out of the Big Bang, to the diversity of at least 118 elements that we see today? This is Space Time. Still to come, NASA's next cosmic map maker. And later in the Science Report, the World Meteorological Organization warns that El Niño conditions are likely to last until at least April next year. All that and more still to come on Space Time.
This episode is brought to you by Dragon Ball Legends, the ultimate Dragon Ball experience on your mobile device. Dragon Ball Legends features action-packed anime action RPG gameplay with Goku, Vegeta, Trunks, and all your favorite Dragon Ball characters. Summon your favorite characters from popular Dragon Ball anime series, such as Dragon Ball Z and Dragon Ball GT to Dragon Ball Super. Fight in real time against friendly or rival Dragon Ball players from across the globe in live PvP battles. Enter ratings matches with your favorite Dragon Ball characters and earn rating points and rewards. Unite with friends to defeat powerful foes in co-op. Dragon Ball Legends features the best anime fighting scenes on your mobile device. And now, Legends Festival is on, so you can get up to 300 free summon tickets. Are you ready? Download Dragon Ball Legends today. Available for free on both iOS and Android devices.
You're listening to Space Time. Space Time with Stuart Gary.
Key elements are now coming together for NASA's new SPHEREX mission, a new space telescope designed to make the most detailed map of the universe ever created. The Spectrophotometer for the History of the Universe, Epoch of Reionization and ISIS Explorer, or SPHEREX for short, is slated for launch in April 2025. The strange-looking spacecraft resembles a giant 3.2-metre-wide bullhorn, its distinctive shape dominated by a series of cone-shaped photon shields, which are now being assembled in a clean room at NASA's Jet Propulsion Laboratory in Pasadena, California. The three cones, each nestled within the other, will surround the SPHEREX telescope to protect it from light and heat from the Sun and Earth. The spacecraft will sweep over every section of the sky, scanning it like the inside of a globe and completing 2 full sky maps every year. SpheriX Deputy Payload Manager and Payload Systems Engineer Sarah Suska from JPL says the observatory has to be extremely agile as the spacecraft needs to move relatively quickly as it scans the sky. SpheriX will help scientists better understand where water and other key ingredients necessary for life originated. To do this, the mission will measure the abundance of water ice in interstellar clouds of gas and dust, where new stars are born and from which planets eventually form. It'll study the cosmic history of galaxies by measuring the collective light they produce. Those measurements will help tease out when galaxies begin to form and how their formation has changed over time. Finally, by mapping the location of millions of galaxies relative to one another, SpheriX will look for new clues about a phenomenon known as cosmic inflation, which took place during the first fractions of a second after the Big Bang. Now, according to inflation theory, the universe expanded exponentially fast for a fraction of a second after it was created. Cosmologists introduced this hypothesis back in 1981 to solve several important problems in cosmological science. Now, one of these problems is the horizon issue. Assume for a moment the universe isn't expanding. Now, imagine a photon was released from the very early universe and travelled freely until it hits the north pole of the Earth. Now, imagine another photon released at the same time but in the opposite direction, and it hits the Earth's south pole. Now, these 2 photons would be unable to exchange information from the time they're released. That's because the time required to send information from one to the other will be 2 times the age of the universe. So we can think of the photons as being causally disconnected. They're outside each other's cosmic horizon. However, in the real universe, we observe that photons in opposite directions must have communicated with each other somehow, because the cosmic microwave background radiation, the leftover heat from the Big Bang 370,000 years after creation, is almost exactly the same temperature in all directions, 2.7 degrees above absolute zero. In other words, no matter which way you look in the universe, everything, generally speaking, looks the same. Now, the problem can only be solved by the idea of the universe expanding exponentially for a short period of time after the Big Bang. Before this period of inflation, the entire universe could have been in causal contact with an equilibrium of common temperature. In other words, widely separated regions today were actually very close together in the early universe, explaining why photons from this region have almost exactly the same temperature. SpheriX will study this cosmic inflation by detecting infrared light at a range of different wavelengths. Problem is, infrared lights also heat radiation because all warm objects, including the SpheriX spacecraft, generate it. Even the spacecraft's telescope will create infrared radiation. And because this light would interfere with its detectors, the telescope has to be kept cold, at least minus 210 degrees Celsius. And this is where the 3 photon shield cones come in. The outer photon shield will block light and heat from the Sun and the Earth, and the gaps between the cones will prevent heat from making its way inwards towards the telescope. But to ensure SpheriX gets down to its frigid operating temperature, it also needs something called a V-groove radiator, 3 conical mirrors, each like an upside-down umbrella, stacked on top of each other. Sitting below the photon shields, each is composed of a series of wedges that redirect infrared light so it bounces through the gaps between the shields and out into space. This removes heat carried through the supports from the room temperature spacecraft bus, which contains the computer and electronics. The heart of SpheriX is of course its telescope, which collects infrared light from distant sources using 3 mirrors and 6 detectors. The telescope is tilted on its base so it can see as much of the sky as possible while remaining within the protection of the photon shields. Built by Ball Aerospace in Boulder, Colorado, the telescope arrived at Caltech in Pasadena, California back in May, where it was integrated with the detectors and the V-groove radiator. Then at JPL, engineers secured it to a vibration table designed to simulate the shaking and rocking that the telescope will endure during the rocket's ride into space. After that, it went back to Caltech, where scientists confirmed its mirrors are still in focus following the vibration test. The mirrors inside SpheriX's telescope collect light from distant objects, but it's the detectors which can see the infrared radiation the mission's trying to observe. A star like our Sun emits the entire range of visible wavelengths, so it's white in appearance, although thanks to its atmosphere it looks more yellow to our eyes. A prism called a spectrograph breaks down that light into its component wavelength colours, a rainbow. And different chemical signatures become evident at different wavelengths, thereby allowing us to work out what the light source is made from. This is spectroscopy. And Spherex will use filters installed on top of its detectors to perform spectroscopy. Only about the size of a cracker, each filter appears iridescent to the unaided eye and has multiple segments to block out all but one specific wavelength of infrared light. Every object Spherex observes will be imaged by each individual segment, enabling scientists to see the specific infrared wavelengths being emitted by that object, whether it be a star or a galaxy. In total, the telescope can observe more than 100 distinct wavelengths, and from that, Spherex will create maps to the universe unlike any other that have been made before. This report from NASA TV.
Spherex is NASA's latest Explorer mission in astrophysics. It's a small telescope, but it has this unique and powerful capability of doing spectroscopy everywhere.
We are going to survey the entire celestial sphere and collect a data set that will help us answer 3 fundamental science questions.
It's going to tell us about the origin of the universe, the birth and formation history of galaxies, and the abundance of essential molecules such as water in the early stages of star and planet formation.
The great thing about Spherex is not only will we view the entire sky 4 times, but we will see it in nearly 100 near-infrared colors, and that's really never been done before.
According to our current understanding of the universe, we think that in the very earliest times, and I'm talking here a fraction of a second, much less than a nanosecond, the universe appeared to have gone through an accelerating expansion called inflation. And this is really a profound idea, and we're very interested to test it. And so one way to do this is to look at how matter is distributed over the universe. We want to map hundreds of millions of galaxies in 3 dimensions. What Spherex does, in addition to mapping out all these galaxies, is we cover the whole sky. So we can measure these galaxies over the largest part of the range we can see, which is the entire sky. And we want to cover the full range of distances from today to as far back as we can see.
We know there are about 100 billion galaxies in the universe, maybe more, but we still don't have a good understanding how these galaxies came to be. Did they all form at the same time? Did they change in size and luminosity or brightness over time? So the intent with Spherex is for us to figure out the formation history of galaxies, where do they exactly form, and how do they grow over cosmic time. And that information is crucial for us because that'll allow us to separate various theories we have right now on the formation and growth of galaxies.
Every day, we all pick up a bottle of water and we drink it without thinking. But to scientists, we still don't understand how this water arrived at Earth. Where was it formed? How did it get here? And this is an area in which Spherex will make major strides. Water molecules bounce around in interstellar space, and every once in a while, they will impact a small dust grain. When a water molecule collides with one of these dust grains, it freezes on the surface. It doesn't leave the surface. And these ice-covered dust grains participate in the collapse to form regions where new planets are formed. Spherex, for the first time, will allow us to directly measure not just the location of these key ingredients, but the abundances of these key ingredients.
We expect to have spectra of order 500 million galaxies, hundreds of millions of stars.
We will really see anything that is observable in near infrared, and that's a lot of things.
And so we can expect some exciting and unusual discoveries that come from this.
This is Space Time.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
And time now to take another brief look at some of the other stories making news in science this week with the Science Report. The World Meteorological Organization says the current El Niño conditions are likely to last until at least April next year. The WMO says El Niño, the climate pattern currently driving warm, dry conditions across much of Australia, is likely to peak as a strong event between now and January, with a 90% chance it will continue throughout the Australian summer. The organisation says based on historical patterns and current long-range predictions, El Niño had previously been predicted to gradually diminish during the spring. Researchers have developed an artificial sensor that can recognise fine fabric textures such as corduroy and wool with high resolution, very similar in fact to a human fingerprint. The findings, reported in the journal Nature Communications, may help improve the abilities of robots to feel subtle textures and sensations, improve human limb prosthetics, and could eventually be applied to virtual reality. The key is a flexible slip sensor, which mimics the features of the human fingerprint and allows the system to recognise small features on surface textures when touching or sliding the sensor across the surface. Combined with machine learning, the sensor was able to identify 20 different fabrics, including linen, nylon, polyester, and seersucker, with up to 100% accuracy. Well, if you ever listen to Space Time on YouTube, you'll undoubtedly notice the rather handsome-looking gentleman on the cover and assume it's me. Well, the bad news is it's not. Rather, it's an artificial intelligence interpretation of what it thinks I should look like. Now, two leading publicly available artificial intelligence text-to-image generators have created images of what the average surgeon is supposed to look like. And they've wound up magnifying existing stereotypes by concluding that the average surgeon is 98% white and male. A report in the Journal of the American Medical Association describes how the DALL-E 2 Mid-Journey and Stable Diffusion AI image generators were each asked to create images of different surgical specialities. While the DALL-E 2 generator did a reasonable job of reflecting surgeons' true demographic data, the Mid-Journey and Stable Diffusion generators created fewer than 2% of images as female and fewer than 1% as non-white. Adding some geographic information to the prompt did help increase the number of non-white images, but not always the number of female images. So, another example of even with artificial intelligence, it really is a case of data in, data out. A lot of towns and cities have legends of giant wild cats, usually lions, leopards or tigers, that have escaped from the circus and are now living in local forests or bushlands feeding off the wildlife. There have even been lots of images and photographs showing what appear to be unusually large black cats prowling along the tree line of the Blue Mountains west of Sydney. But debate continues on whether it really is a panther or just a really big old black house cat. Tim Mendham from Australian Skeptics says now a bunch of Derbyshire locals claim to have seen their own black panther during an expedition to the Peak District.
There's big cats everywhere. They're all over the world, of course, big cats. Some of them actually where they do have big cats. There's a lot of other areas where they supposedly don't have big cats. But this recent story was interesting, primarily due to the video. But when I first wrote about this, I had to look at the entire headline of this article, which says, Derbyshire big cat video shot in the Peak District shows men shocked after they spot the big black cat just 6 feet away. Now, there's a lot of caveats in that because the video doesn't show the cat. It shows the shocked men saying, there was a cat.
Oh, look, it's big.
Well, it's actually after the fact. They're looking shocked, right? The problem is, a fellow out there with his sons, 2 sons in their 20s, looking for, I don't know, it was a paranormal group, so they're looking for something paranormal.
Of course they
And
were.
of course they found it. So they told the Derbyshire Times that someone had found some skeletons in a tree, like an animal skeleton, and therefore there must be a big cat leaving their food up there, etc. So they went out, they were filming a live Facebook video, right, as people do, saying this is our investigation, here we are. And suddenly the 2 sons noticed something strange. And what the father said that my sons saw what they could only describe as a very large, silky black cat with a very long, swoopy tail. It was much bigger than a fox, and it moved exactly like the big cats you see on TV. All on good, okay. Feral moggies can get quite large.
Oh, yeah, I've seen some huge calico
So
cats.
we're thinking, there they are with their Facebook video, filming it live, and the father then pointed out they only saw it for 30 or 40 seconds, and one of the sons turned in shock. And then the cat trotted off into the distance straight away. It was just 6 feet away from me and my
So
son.
if it trotted off into the distance, it was a one-eyed cat then.
But hang on, they're filming live. The cat was there for 30 or 40 seconds, which is a long time. I mean, people film fireballs in the sky totally unannounced, and they're not prepared for it, and they last seconds, right? But here they are, 30 or 40 seconds of filming with a cat that's 6 feet away from them, 2 metres, right? And they don't have any video of it. All they have is video of the men going, I was shocked. So you wonder about either they are the world's most inept paranormal creature hunters, or they're making it up. And I don't know which.
Which do you believe?
Which do I believe? But if somebody was there 6 feet from me for 30 or 40 seconds, I think I'd get a pretty good. I could take a phone out of my pocket and start filming and still get a good shot of it. But no, there was no film of it. So, oh dear.
That's Tim Mendham from Australian Skeptics. And that's the show for now. Spacetime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. Spacetime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the Spacetime store for a range of promotional merchandising goodies, or by becoming a Spacetime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more Spacetime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our Spacetime YouTube channel, and on Facebook, just go to facebook.com/Spacetime with Stuart Gary.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.